Hi and welcome to this video. In this video we are going to talk about EEG. EEG is electroencephalography or electroencephalogram, which is the electrical activity of the brain, and we measure that by using electrodes on the scalp, right? So we are talking about EEG measurements in this lecture. Now, the neural matter under the skull, when it is activated, when the neurons are firing, they generate electrical potentials that can be picked up by electrodes on the surface of the brain. But of course, our skull is a very good insulator, and therefore the activity is very, very small. And not just that, the nerve potentials themselves are very, very small, right? And therefore, when they cross the skin and the scalp and the skull, the potentials drop very, very much. And therefore, what we actually measure is not the activity of single neurons under the electrode, but masses of neurons being excited at the same time. So those electrical activities are picked up by these electrodes. Now this is how a EEG machine looks. I'm sure you have seen this in various places. Usually you put electrodes on the head using a cap, and you connect these electrodes to a EEG measurement device. And here you see that the EEG is appearing on the screen. Now the EEG device itself looks very similar to the ECG kind of device. The only issue there is that ECG is a very simple measurement because the signal levels that we are measuring are quite high. Even though it's just a few millivolts, it's quite high compared to EEG, where your signal levels are a few microvolts, right? And to record those signals is much more difficult than recording ECG signals, right? Okay, so that's how a EEG machine looks. And there is standard ways of putting the electrodes on a person's head. It's not like you put it anywhere you want. There are standard ways of doing that, and the top two pictures are showing you the 1020 system, the international 1020 system, which is a very common system that is used to put electrodes. The 1010 system has many more electrodes than the 1020 system. So these white electrodes are the additional electrodes in this system. And you can record from all these to record activity of various parts of the brain. This is how a typical EEG graph looks like. So now, what we have done here is we have measured from various electrodes that have been put on the scalp, right? And you can do two kinds of measurements. You can measure between any two electrodes on the scalp, and that helps you to look at different regions of the brain. Or you can look at the potential of one of those electrodes with respect to the reference. So you could do either one of them. And one of the things that you see in this EEG graph is that they seem to have a certain rhythm to it, isn't it? Okay, it doesn't look like exactly like a sine wave, this signal, and this signal, but they seem to have some frequency built into it, isn't it? This frequency is called the alpha waves, and you can record the alpha waves especially from your visual part of your brain, and especially when you have closed your eyes. Okay, so that's a normal EEG. And here you can see some kind of changes in the EEG when a person is sleeping, right? So you can see these changes here, which seem to be kind of regular, and there is these changes at this point from the baseline frequency, and that these kinds of changes can be detected during sleep. And as you develop the skill to look at an EEG, you can understand what these different changes signify. Now, one of the ways in which EEG is used is not just as just taking it in when the person is at rest, but you try to activate the brain by doing something. And this you especially do when you have like epilepsy or some kind of seizures and you want to study the brain and you want to record and find out what is going on, you have these activation procedures that help you to kind of push the brain into a seizure mode so that you can be recording this EEG. So you could have you could do this by various processes like hyperventilation. You could do it by intermittent photic stimulation, which is basically you close your eyes and you shine light on your eyes, right? And you'll be able to see something, and that kind of triggers the brain. Or you can use sleep deprivation so that people are deprived of sleep, and when they come to the lab, they go off to sleep, and then you can observe their EEG during sleep, and that gives you some information. So when you hyperventilate, this is a EEG trace of a patient when he hyperventilated, and then you can see that the brain has gone into some kind of state where you have these very low frequency signals running in the brain as compared to normal. And you can see this is the normal curve and the previous one was the abnormal curve, and you can see the difference. So you can also see that this is the normal curve, and you can see that this is when you have photic induced seizures. So these lights induce a seizure, and you can see that the curves look very, very different from a normal EEG, isn't it? So those are some diagnostic tools that you can use to figure out what's going on. Now, the problem with EEG, as with all biosignal recordings, but especially with EEG because of its low amplitude, is that there are a lot of artifacts, right? And one of the artifacts is because of sweat. This EEG doesn't look normal at all, right? Because of sweat, you can see that there are these wild swings in potential in the signal that you're getting, and that's not really good. And similarly, you would get some kind of distortion in the EEG signals that you're measuring because of tremors in other parts of the body, right? Your EEG may be fine, but other parts of the body, just because the EEG signal is so small, cause the EEG electrodes to pick up these electrical signals, and it may look as if your EEG is abnormal, while all that is happening is that some tremors from somewhere else are being picked. So you have to be careful in detecting and making sure that you're not getting these artifacts while you're recording EEG. So that was a very short introduction to EEG in clinical practice. Hopefully that helps, and if you want to know more, I'll put some stuff in the reading list that you can take a look.